Our goal today is to be able to solve multi-step linear equations in one variable. Let's begin by identifying parts of an equation. Here is an equation. How do I know it's called an equation? Look at that word equation, how it looks like equal. An equation has an equal sign in it. So this is an equation. The equation is made up of expressions. On this side of the equal sign, we have an expression. An expression does not have an equal sign in it. The equal sign makes the equation. The expression is made up of terms. Each of these that are added and subtracted together, these are each called terms when they are added or subtracted together. Terms. There are 4 terms on the left side of the equation. There are like terms, the terms that have x's in them, like the 3x and the negative 6x. These are called like terms because they are like each other in that they both have variables. 3x and negative 6x are like terms. Another pair of like terms are negative 4 and positive 2. Negative 4 and positive 2 do not have a variable next to them. So these are like terms because they're like each other, but more specifically, these are called constant terms because they don't have a variable. What's the variable? This is the variable, the x. This letter right here, that's called a variable. The number that's multiplied to the variable, that's called the coefficient. The 3 is called the coefficient. We're going to look at doing mostly solving equations today. But to get to solving equations, we need to remember what it means to simplify an expression. That means combine like terms. We're going to start simplifying expressions. Then we'll get into solve an equation. That means to find the missing value of the variable. First, simplify each expression. Notice that these are not equations. There's no equal sign. So simplify the expression. That means we're going to combine like terms. So let's look for terms that are like each other. 3x and negative 6x, we pointed out before, are like each other. 3x minus 6x makes negative 3x. Then I can combine the constant terms, negative 4 and positive 2. Negative 4 plus 2 makes negative 2. This has an x in it. This doesn't have an x in it. So I cannot combine these terms anymore. This is my final answer, negative 3x minus 2. Why don't you try number 2, pause the video, come back and see how you did. Did you get 12x plus 1? If not, look back at my steps and see if you can follow them. Number 3, we have to use the distributive property. Distribute 3 to the quantity 2 minus c. 3 times 2 makes 6. 3 times negative c makes negative 3c. And then we write the rest of the equation that we see, minus c. Now we can combine like terms. Negative 3c and negative c are like each other. Together, that makes negative 4c. Remember, this is like an invisible 1. Negative 3c minus 1c. Also, we have the 6. It is not like anything else. So I'm just going to write it in front of what I have before. And then I have my final answer, 6 minus 4c. This is a constant term, this is a variable term, so I cannot combine those. That's my final answer. Again, pause the video, try the next one, come back and check your work. Did you get 2c minus 4? Hope so. Now, we solve each equation. See how there's an equal sign now? Then we will check the solution using the substitution property. Let's start by solving the equation. If I see an equals, I'm going to draw a line to remember that I have two sides to the equation. And first thing I do on the side that has many terms is I'm going to combine like terms. So I see 9d and negative 2d. 9d minus 2d is 7d. Then I'm going to write the rest of what the equation says. Plus 4 equals 32. Now I'm trying to get the d by itself. Remember our order of operations, PEMDAS. Some people like to say, please excuse my dear Aunt Sally. PEMDAS or GEMDAS. Some people write it that way. Parentheses are grouping, then exponents, multiplication, division, adding, subtracting. Well, when we solve an equation, we work backwards. So we start with adding and subtracting. If we see that first, such as here, I'm adding 4. So I'm going to make that plus 4 go away by saying minus 4 from both sides of the equation. What do I have left over? 7d, because those are gone. 7d equals 32 minus 4, 28. Now I can do the multiplication or division. 7 times d, so I divide both sides by 7. Then d equals 4. And there's my answer. D equals 4. But remember that we also want to check our solution using the substitution property. So we're going to take the 4 and we're going to substitute it back into the original equation. 9 instead of d, we're going to put 4 plus 4 minus 2 times 4 equals 32. 9 times 4 is 36, plus 4, 2 times 4 is 8. And we keep simplifying this expression. 36 plus 4 is 40. And 40 minus 8 is 32. Because 32 does equal 32, we know our answer is correct. Pause the video, try number 6, and come back and check your answer. Did you get x equals 6? Did you check to make sure 6 is the correct answer? Let's practice another way of checking using the calculator. Let's take 6 and store it in for our variable x. We're going to type 6. Then we find the store button, gives a little arrow, and then we find the variable we need. If it's just x, we can use this variable button, enter. Now, anytime we press X, it thinks we mean 6. Now we can write this expression and see if it equals 20. 8x minus 3x minus 10. Enter. We got 20, so we're correct. Even if the answer is not for the variable x, we can still check it using the calculator. Let's look at this one, number 5, where our variable is d. D is 4. So I'm going to press, well, first I'm going to clear my screen, 4, store, and I see that d is in green right here. So I have to press the alpha button and then that button for d, enter. Now I'm going to type this expression, 9d plus 4 minus 2d. 9 alpha d plus 4 minus 2 alpha d, enter. 32, and that's what we were supposed to get. Let's try another one. 2w plus 3 times the quantity w plus 4 equals 27. Again, I have an equation to solve. I'm going to draw the line. Now in this one, first we need to distribute. Distribute the positive 3 to both of the terms in the quantity. Let's rewrite what we have. 2w, I didn't change that, plus 3 times w is 3w, 3 times 4 is positive 12, equals 27. I didn't change that. Now we can combine like terms. 2w plus 3w makes 5w plus 12 equals 27. Now I'm trying to get w by itself. Do the stuff farthest away from the w, minus 12 both sides, left 5w equals 15. Now divide, get rid of the 5, divide by 5, w equals 3. Let's check our solution to make sure we are correct. Take our 3, put it in for the w in the equation. So here's our check. 2 times 3, because w is 3, plus 3 times the quantity, here's w, that's 3, plus 4 equals 27. 2 times 3 is 6, plus, do the parentheses first when I'm evaluating, 3 plus 4 is 7. 6 plus 21 equals 27. 6 plus 21 does equal 27. We're correct. Again, pause the video, try number 8, come back and check your work. Did you get x equals 9? If not, let's take a look at some of the steps you might have missed. Up here when we first distributed, remember that we have to distribute the negative 2. Negative 2 times x is negative 2x. Negative 2 times negative 5, positive 10. So perhaps you messed that part up? Maybe not. Maybe you got x equals 9. Let's continue. Let's look at number 9. This one looks like the last one, except that we have a fraction multiplied to a quantity. It's easier if we don't have a fraction or a denominator, so to get rid of a fraction, we can multiply by the reciprocal. Remember the inverse property of multiplication? Times this side of the equation by 2/3 times this side of the equation by 2/3. Multiply by the reciprocal. That way, the fraction has gone all together, and we're left with 3x plus 5 equals negative 6 times 2 is negative 12. Negative 12 divided by 3 makes negative 4. So that equals negative 4. Now I can concentrate on moving stuff away from the variable. Subtract 5 from both sides. 3x equals, adding those up, negative 9 dividing by 3, x equals negative 3. Again, we can check our answer by plugging it back into the original equation. Let's go ahead and do a check. Our original equation says 3/2 times the quantity, 3 times the x value, negative 3, plus 5 equals negative 6. Working inside the parentheses first, negative 9 plus 5. Negative 9 plus 5 is negative 4. And 3/2 times negative 4, negative 12 divided by 2 makes negative 6. We're correct. Why don't you pause the video, try number 10 on your own, come back and see how you did. Did you get x equals 3? Did you remember to multiply by the reciprocal, 5, which is the same as 5 over 1? Did you get negative 5 on this side when you did that? Let's look at just a couple more. Here are some more examples where we have denominators or fractions. If we're dividing by a number, we don't want that denominator to be there, so the opposite of dividing is multiplying. So we can start by multiplying both sides by 5, and that takes care of that denominator, and on this side, we're left with just x minus 2 equals, on this side, 2 times 5 is 10 over 3. We still have the denominator of 3, so we can now multiply both sides by 3. That takes care of that denominator. On the left side, we have 3 times the quantity x minus 2 equals 10. I can distribute this 3 for 3x minus 6 equals 10, and then I can work my way to get the x by itself. Add 6 to both sides, so 3x equals 16, and then divide both sides by 3. X equals 16 thirds, or 5 1/3. Why don't you pause the video, try number 12, come back, and check your work. Did you get x equals -3/7? If not, did you get x equals -9 over 21? Remember that you can simplify a fraction by dividing by the greatest common factor, or use your calculator's fraction tool to simplify it. 9 divided by 3 makes 3, and 21 divided by 3 makes 7. Take a few minutes in your own words to compare and contrast the directions, simplify an expression, and evaluate an equation. See you in class.